Hey guys, welcome back to my YouTube channel, and today I'm recording 5070/22 May June 2016 paper. This is going to be full of a lot of explanation, tips, and how to solve your paper and how to nail your CI examinations of chemistry. So without any further ado, let's begin the theory paper. Okay, so the first question that we're doing section A, make sure you read all of, like go through all of these things, it's important. All right, you should go through them because usually students do not care about it, but we should read it anyways. Choose from the following polymer to answer the question. This is section A and it is of 45 marks. These are so many polymers that we have, and they have all different types of bonds. Some have amine bonds, some have. Alright, let's get to the question part. Each polymer can be used once, more than once, or not at all. Part A says which two polymers are polyesters. Polyesters. If you look at A, it has nitrogen in it. It's not a polyester. A polyester must have O and C double bond mainly. Alright, so let's see this. This one is not possible. Polymer B does not have C double bond O. So we got polymer C because it has this thing, Alright. And if we go down, polymer D has O. This is not the right answer. This is also not the right answer. And then once again, here we come to polymer H. And polymer I, again, it does not have polyester. It isn't a polyester. So the answer for this is C and H. Moving on to part B, which polymer is used to make both cling film and plastic bags? Cling film and plastic bags are usually the one that with carbon and hydrogen bonding. Alright, it's usually addition. It's usually an addition polymer. If I'm right, it's actually addition polymer, the one with double bond. And like there are two types of polymer, condensation and addition polymer. I'm sorry for kind of getting confused in it, but anyways, so here we see this is not the right answer. Polymer B is the right answer because this is used for making plastic and polyethylene mainly. Moving on to part C, give the letter of an addition polymer. Yeah, right. We were talking about addition polymer. Addition polymer, once again, polymer B is addition polymer. And a condensation polymer. For condensation, we can have, alright, let's sort them out. Polymer A is condensation. Alright. Polymer B is addition. Polymer C is again condensation. See, the properties of an addition bond is that it has single bonds with carbon. Carbon has single bonds, alright? This. Polymer D is again condensation. Polymer E is addition. See, it has repeat units. Alright, you mean this. And if you talk about a single unit, if we like just, get rid of this and get rid of everything. Alright, this is mainly the polymer, alright. It's like that, right? Polymer F is again addition. Alright, and polymer G is condensation. Condensation, and this is addition. Alright, so you can write any of the letters over here. Give the letter of a polymer that is saturated hydrocarbon. Saturated hydrocarbon will be, of course, let's go through it. A is not a saturated hydrocarbon. B is a saturated hydrocarbon, so B can be your answer. Besides it, C is not saturated, D is not saturated, and then we look at E, which I have kind of messed up. So like if we erase all this, so yeah, B is also a saturated hydrocarbon. Besides it, we do not have any other saturated hydrocarbon. Moving on to part E, which polymer could be a part of a protein. Protein means it must have, nitrogen in it. It must have amine bond, alright? Let's just forget about my writing skills, alright? I mean, not really a pro at it, but let's try. We'll get better over time. So if you see over here, for protein, we must have nitrogen, hydrogen, carbon, and all these. If we look at all these polymers, so it is clearly visible that polymer A, polymer B, polymer C, they all have different kind of bonds. That wouldn't be an amine bond. Alright, if we look at polymer F, no. Polymer G, yes, because it has amine bond. You see this? And it is being repeated. So the answer is G for sure. Now moving on to question number 2. Yeah, fine. Alright. Hydrogen fluoride has a simple molecular structure. It is soluble in water. Suggest one other physical property of hydrogen fluoride. Hydrogen fluoride has hydrogen bond. Okay. On O levels point of view, if we see, it is simple molecular structure. So any property that matches a molecular structure property is what you're gonna write over here. So you can write low melting point, or you can write it does not really conduct heat or electricity. These kinds of points you can mention over here, any one of it, and you'll get 1 mark. B. Hydrogen fluoride dissociates in water to form dilute hydrochloric acid. Write an equation to show the dissociation of hydrogen fluoride. So for the dissociation of hydrogen fluoride, we'll write an equation. So it will be something like HF alright, and dissociation for it will be hydrogen will be the proton plus F F minus. Alright, this is the dissociation equation for this. Explain why an acidic solution is formed when hydrogen fluoride dissociates in water. So as we can see over here, hydrogen ions are present. Hydrogen ion is the reason for the acidic solution. Alright, this is the reason for the acidic solution. Moving on to part C, dilute hydrofluoric acid reacts with aqueous calcium hydroxide. What is the minimum volume in centimeter cube of 0.15 mole per dm cube CaOH2 required to react completely with a solution containing 0.2 gram of hydrogen fluoride? We're supposed to find volume over here. First of all, if we look at this, we can see we have the concentration. Alright, what is the minimum? Dilute hydrofluoric acid reacts with aqueous calcium hydroxide. What is the minimum volume in centimeter cube? So first of all, we need to give the answer in centimeter cube. But for getting the answer, we need to look at the data that we have given with 0.15 mole per dm cube CaOH2. Alright. And this is required to react completely with a solution of 0.2 gram of HF. So for HF, we need to refer to our periodic table. Alright, and I'll get a calculator for me so that we can, solve this. Alright. So we need to first of all find hydrogen. Fluorine is 19 and hydrogen is 1. Which is the MR, alright? MR of HF. Can you just reach to that page quickly? Yep, so here it is. MR of HF, alright? And this is gonna be 20, alright? Now what do we have to do is that find the moles of it. Alright, so moles is equals to mass upon MR, that is 0.2 gram upon 20, which would give me an answer of 0.01. Alright, so we have moles of HF, moles is equals to 0.01. Alright, now moving on to, we have the concentration over here 0.15 moles. If we look at it, it is going to be, we are going to find the moles of CaOH2, and that would be as we can see over here, 2:1 ratio. So we are going to somehow find it by using this ratio. That is going to two is to 1. Alright, here we are going to get about it. I'm really sorry for this delay, but it's really lagging a lot. 0.5 into 0.01. Alright, and we'll get the answer, which is going to be 5 into 10 to the power minus 3. These are the moles that we have. Alright, if you use the formula, and C is equals to V is equals to C upon N upon C. Actually it goes like CV is equals to N. If we derive it, it's going to be N upon C, right? So N upon C would be 5 into 10 to the power minus 3 upon 0.15, which is going to be answer upon 0.15, 0.03, 0.001, 3 3 3 dm cube. Now for centimeter cube, we're going to multiply it and it is going to be 33.3 centimeter cube. Alright, moving on to part D. Magnesium reacts with fluorine to make the ionic compound magnesium chloride. Predict two physical properties of magnesium chloride. Magnesium chloride is actually, if you talk about physical properties, it will magnesium chloride, right? So magnesium loses. Okay, so for this, we will first look at. Let me tell you something before it. Ionic compound. We're talking about ionic compound over here. So it has high melting point, high boiling point. It can conduct electricity. All that in aqueous form, it can conduct electricity. So moving on to part 2, explain in terms of electrons how a magnesium atom reacts with a fluorine molecule F2 to make magnesium ion and two fluoride ions. Alright, it is because magnesium loses 2 electrons. Alright, and fluorine gains 2 electrons. In this way, they form an ionic compound. 2 marks it was, and this was a pretty easy question and you can easily score 10 marks. This is it for the video. I will upload part 2 really soon. Stay tuned, keep studying hard, and best of luck for your exams.